Hello, college algebra. How you guys doing? Started this a little bit late getting up, getting posted. The Our topic today is very important, used all over the world, and it will be part of your life numerous times in your life. And that is the concept of amortization. That's a 50-cent word, amortization. Amortization. Let me give you an example. Your payment on a $2,300 or $23,000 car loan at 3.9% APR is $358.79 a month for 6 years. This is an example of an amortized loan. Home mortgages are another example. Now, what makes a loan amortized is that there is an amount A being repaid in equal payments, or equal payments at the end of each of in payment periods, usually months, right? In payment periods, usually months. Right? At some given nominal interest rate, right? So this is different. Like, for example, if you have you put $2,000 on your credit card, number one, somebody needs to take a frying pan to your head. Okay, you need a coconut to drop on your head. Cuckoo, cuckoo. But if you put $2,000 on a credit card, the payment you make whatever payment, your next month payment will probably not be the same unless you choose to make it the same. But like your minimum due, if you make the minimum payment, which you really need two coconuts in your head if you only do minimum payment, but if you did, the next month it would be different, and the next month different than that, next month different than that. And you may choose to do 200, 200, 200, 200, 200. You may choose to do that, but when you pay back a loan based and the amount you pay is based on how much you still owe, that's not an amortization. Every monthly payment in an amortization, and for that matter anything else, but amortization in particular, has two parts. One part goes toward the repayment of the loan, right? And so there you are paying back principal. And that is what you borrowed, the principal, right? All right. So principal can be what you start with in an investment, where you have the money, but it can also be what you what you borrow. That is sometimes referred to as the principal of the loan. And then the second part of your payment is interest. Now keep in mind the monthly payment stays the same. So the amounts for each of these changes every month, but they always add up to R, your monthly payment. It's always the same amount per month for a given time period. All right. Now, you might remember from last section, 5.5, the present value, A, of an ordinary annuity is given by this formula here, remember? All right. By the way, if you haven't done any of these problems, you're going to be fairly lost today. If you haven't done these problems, you need to get to it. You're behind. You're behind. That's one thing that concerns me about the online is I don't think people, it's even harder to catch up in some cases. But so the formula was this, right? And then we gave the second part a name, which was that odd. That was that odd notation, right? We're going to solve that thing in yellow. We're going to solve that for R. We're going to solve it for the amount of our payment. Okay? So when we solve that up there for R, it's not hard. You multiply both sides by the inverse of that fraction, and you get this down here. So A equals that. If I want to solve for R, I divide by this. And so this equals R. Another formula for that. Okay, we're going to use more of just this. Okay, now you're going to have these formulas. The question is, you got to know how to use them. Right. By the way, these slides are up on Canvas. It's in the same folder where the daily class notes are. This is an important table from your book. We're going to be using this today, right? On page 228. Notice what it gives you. It gives you the formula we just had right here. But there's other things too. You're making a series of payments. In other words, you're the one providing the annuity, so to speak. You're providing an annuity to the lender. You're providing a stream of payments to the lender. All right? In exchange for money that the lender gave you at the beginning. All right? And so this is what your payment's going to be. We're going to work with that one. Your outstanding balance at the beginning of the kth period. So if it's months, after 10 months, K is 10. This is the formula for it, right? Interest that you paid in the kth period. Remember I told you every payment R consisted of interest and principal. These two equal R. When you add them together. When you add them together, they equal R. Interest plus the principal in any month equals the payment. All right? And these are the formulas. Right? Now, when you understand how these are computed, we're going to do these today, and we're not going to mess with a lot of these formulas. Okay? So the other thing you might be interested in is that when you pay your payment, like you make your car payment every month for around, I don't know, 6 years or something, how much interest did you pay the entire time? Right? You paid for the car, however much that was. How much was your total interest? That's your last formula down there, number 5. All right? So let's have a look at this. All right? We're going to get to the concept here. This is on page 228, 229. An amortization schedule. An amortization schedule. Right? Insurance has this, all kinds of annuities. If you ever get a loan on a house, a mortgage, there's an amortization schedule. Now, we're going to see some dynamics on this that I think you're going to find, well, if you're smart, you'll find them useful because you're going to have these in life. You're going to have amortization schedules in your life, whether you know them or not. And I advise you to understand them. So, for example, suppose you had a loan of $2,000. It's to be repaid in equal monthly payments over 4 months at 6.25% interest, compounded monthly. Okay? Right? How's that going to work? Well, I'll tell you how it's going to work. Your payment is going to be given by that buzzard right there. All right? Your payment's going to be given by that. Let's complete this little simple amortization schedule. And you're going to have a homework where you're required to do this, right? Where do you start? You start with the $2,000. Your balance at the beginning of the period, the first period, is $2,000. Right? How much is the interest? Or excuse me, what's our payment going to be that period? Well, if we plug into the R formula, right? This is This is our monthly interest rate, right? Right? We take the 6.25%, divide by 12. Same thing down here. We just plugged into this formula. 2,000 is our A, and we wind up with 506.53. 506.53. So that's going to be your payment every month. So here's what we can do. You ready? We're going to take a different color, say purple. All right? 506.53. 506.53. 506.53. You're going to pay that every month. That's your payment. 506.53. Right? Now, your interest. Let's do the interest. What's going to determine your interest? You're making your payments at the end of the month. And so you've had, before you make this payment here, you've had $2,000 of somebody else's money for 1 month. So what interest is due on that? Right? That's going to be, what's the monthly interest rate? 0.0625 divided by 12 times that amount times 2,000. Okay? And you go to your calculator and you get that amount. It's going to be $10 and 42 cents. Okay? $10.42. So your payment was $506.53. $10 of that was interest. So how much of it did you pay to pay off your loan? How much actually went toward the loan? Well, it's going to be your payment minus this. So what goes in this box here is going to be 506.53 minus 1042. And that's going to be what? 496. 496. And let me get another color here. This is going to be 496.11. All right. Now notice, the student will observe that my interest 1042 plus my principal equaled my payment. Now, what's my balance at the end of at the beginning of my next month? Well, I paid, it was 2,000, but I paid 496.11 toward the 2,000. So this calculation here is going to be 2,000 minus 496.11. And that is going to give me $1,500, and let's see, $1,503.89. Right? Right. When I take the $1,500 and $1,503.89, add 496.11 to it, I get the 2,000. So this is the amount of my loan that I'm carrying over for the next month. And I do the same thing again. I do this with every line. Oh my. Now we're not going to do this by hand. Well, we don't have to. But I want you to know where these numbers come from. Right? And you're going to be responsible for knowing where these numbers come from. So for example, here, where did I start last time? Well, I have my payment. I'm going to start with my interest again. So it's going to be the same monthly interest rate, 0.0625 divided by 12 times, not 2,000 this time, times 1503.89. Because that $1,503.89, that's how much I'm carrying borrowed money for another month. So I owe interest on that amount, not my original 2,000, not my original $2,000. That comes to $7.83. And then I subtract that off my payment. I'm paying this much. $7.83 is going toward interest. The rest goes toward my principal. So up here, I'm going to have $506.53 minus $7.83. And so what's that going to be? That's going to be 490 $8.70. And notice once again, that number plus my interest equals my payment. Right? Then what would I do? I'm not going to finish this table. The reason why is that the very next slide has all this on it. But the total amount of your principal paid, the total amount that you pay toward the loan had better total $2,000. You'll notice that on the next slide. Right? You'll notice that on the next slide. And your balance is going to come down to 0. Your balance will come down to 0. So here is your, this I did with a spreadsheet, just brought it in here. This is called, when that table is complete. So this right here, this is that table we were doing on the last slide. Okay. Notice several things. Number one, payments are the same every time. Number two, you paid $2,000 in principal. Number three, there was $26 worth of interest. Number four, if I take how much interest I paid plus the $2,000, that equals the total amount of all my payments. Right? So this is called an amortization schedule. And I just set this up in a spreadsheet where if I say I change the interest rate, all that will change. All right, let's go to our next one. So you have a $23,000 car loan at 3.9% compounded monthly for 6 years. Find your monthly car payment. Well, the payment is going to be this right here. It's going to be this right here. So R is going to equal your A, look here, your A, that value right there, that's the amount of the loan, right? That's the total amount. So that's going to be $23,000. My interest rate, oh, what interest rate is that going to be? Per month. Monthly for 6 years. Per month. Per month. How many periods am I going to have? 6 years is 6 times 12 is 72. That's my N. And so my R is going to be 0.039 divided by 12, whatever that comes to. All right, so going back to apply this formula here, I'm going to multiply that $23,000 by my R, which is 0.039 divided by 12. Now I'm going to divide that by 1 minus 1 plus 0.039 divided by 12. Raised to the, notice, the negative in power. So that is the minus 72nd power, minus 72. And like I've been stressing with you, do not compute parts of this and write it down, compute parts, write it down, and then enter those written down values back into your calculator. Because when you write them down, you round. And when you take rounding area, and you raise it to 72nd power, and you multiply it by 23,000, you're going to be off in the weeds. You're going to be off in the weeds. And let's, we go to our calculator. I can't show it to you on this screen, but we're going to go on the calculator and compute that number. That is going to equal $358.79. That's your monthly car payment. Now here is your challenge or homework. Arrive at that number on your calculator. Arrive at this value right here. In other words, evaluate this and get that number. Right? Most of us, when we first start doing this, you'll get that wrong more than once because of the orders of operations and so forth. Right? 2, part B, total interest paid. Now, total interest paid, you see, is right here. Right? It's right there. It's actually not a hard calculation. Because what that's going to be is it's going to be, it's that you use this right here. This is your total payments. This is how much you owed. What you paid over what you owed is the interest you paid. So this is going to be total interest. It's going to be, how much did you pay? 72 times that 358.79. Okay. Now I'm going to use that number on the screen. I'm just writing this down just to show you what I'm doing, but I'm going to use that number on the screen that has all these extra decimal places. And then I'm going to subtract from that. That's how much I paid. 72 payments of $358.79. I'm going to subtract from that how much I owed. That's how much I borrowed. That difference is my total interest paid. And you see that comes to $2,833.04. Always round to the nearest penny. So that is that figure, and this is this figure. Okay. All right. No, especially this calculation here in part A, you're going to need to practice those buzzards to be able to do them on the calculator. All right, so how much do you still owe? How much do you still owe, i.e. your remaining principal, on the car after 3 years? So that's formula 2. So we're going to use this formula here. All right, that formula there. All right, so now notice this funny looking exponent here. Notice that exponent, right? All right, so now we're going to write that, we're going to go over here. This basically, look, this is the same, this is a an amortization, right, kind of format, except that top exponent. So when we do this, our amount remaining, right, remaining principal, equals. Now we go up there, it's going to be R. R is our payment. So that's going to be the 358.79 times big fraction. Times a big fraction, and it's going to be 1 minus parenthesis 1 plus R. R is our 0.039 divided by 12. Right? Now K is at the beginning of your kth period. So after 3 years, this is 36. Right? We already know that N is 72. So we're going to raise that to the, it says the minus N plus K minus 1. So that's the minus 72 plus 36 minus 1 power. Now I'm going to divide that whole thing by my R, which is 0.039 divided by 12. And I want to stress again, you want to use this number on your calculator here with all those decimal places. All right? And so if you've got to go back and figure it out again, do it. Do it. But there's a way to repeat that screen, to repeat that line, to call up that line on your calculator. I'll show you sometime in the live class. So what does that equal? So the amount you still owe on your car after 3 years is that. Right? And so that's going to be 12,489 point, and we round 10. That's the only time you round is your final answer. Your final answer. All right? This is actually a corresponds to an example in the book. There's only 2 examples in this section, and this corresponds to example 2. All right. Now we did not cover the natural log function, so we did not cover the natural log function. So we're going to skip this particular example, and you're not going to be responsible for doing this on future tests, the final. And there is actually, for the homework now, there's two ways of actually doing that. But for the homework, you can leave off problem number 11 for the homework. And this homework will be due. Today is Friday. This homework is going to be due next Wednesday. Next Wednesday, which is April 15th. What used to be tax day, but not anymore, not this year. They did a 3-month extension, so everyone has till July, at least for your federal taxes. So anyway, there aren't many examples. There's only one core concept in this particular section. But the concept is a little hairy with the formulas. And when you get back doing these calculations, you absolutely are going to need practice entering these and understanding those formulas. All right, and then you should be able to find any number on this table, any number. So if I drew one of these tables and I left off a number, you should be able to fill that number in. Okay? You should be able to fill that number in. And for that matter, if I gave you a blank table, and said, find this square right here, right? You should be able to find it. You should be able to find it. That is when you understand amortization. And amortization schedules like this they're going to be part of your life. You go to buy a house, unless you can cut a check for the price of that house, $200,000, you're going to have a mortgage. And a mortgage is nothing but an amortized loan, right? That's it. You make the same monthly payment every month, and the payment is comprised of a principal and interest. Something else I didn't mention is, notice your interest part goes down. As you make more payments, the proportion of your payment, which stays the same, that is made up of interest goes down, and the proportion of your payment that's made up of principal, which is really going toward your loan, goes up. So the mix of these two change. Principal, the part of your payment comprised by principal increases. The part that is comprised of your interest decreases as you go. That's very, very important. And I have a day set aside that I'm going to go over some personal finance, and we're going to have amortization tables. I'm going to show you on a spreadsheet how this kind of stuff works. So we're going to leave it there. You have a good weekend. We are meeting live on Monday. So be safe. Do something fun this weekend. And don't forget to wash your hands.